So we're going to go to Italy. This is now southern Italy. Here is Sicily, and this is part of the Aeolian Islands, to form a volcanic arc in Italy. And the two of the more famous islands here, volcanoes, are Stromboli and then Vulcano. And for this demonstration, we're going to go look at some drone data that was collected at Vulcano. So here is an image of this volcano looks like, this area, and then here is a rock outcrop, and we're going to be processing data from this rock outcrop. This data was collected a few years ago by Ramon Aerosmith with several students from Switzerland, and they were going to use this data to look at how lava can flow in this island and therefore volcanic hazard. So the data that we're showing you today is also processed and is now hosted as a community data set on OpenTopography. And so for future reference, if you would like to access that data, you can come here to OpenTopography. Perhaps some of you are familiar with our user interface. All of these dots are where we have data. And then you'll want to go down to Italy and then to Sicily. And you'll see here, this blue dot is the data set that we're going to be looking at today. So you can click the link for this Faraglione data set, and then you're taken to the page for the data set, which gives you an opportunity to download the data set. We'll come back to this in a little bit. Yeah, so here's that fairly modest sized data set. Feel free to open the pictures. And then hopefully you all have downloaded some version of Agisoft Metashape. Here I have the professional version and it's licensed. So I'll walk you through the demo today. With an unlicensed version, you'll be able to do most of what I show, and I'll show a few later steps, show what you can do with what are the extra capabilities of getting the software licensed. So here is a Metashape window. And when you're processing, the area that you want to come to most is this workflow. And so it's very nice. It's actually organized already in an order that's very, very likely to be the order that you're going to run things in. So the first step you'll want to do is to either add photos or add folder. If you want to add just a lot of data, it's often easier to go to add folder, and then it automatically adds all of the images that are within that folder. So that's what I'm going to do right now. So then it takes you to your window, and so then link the Agisoft to wherever you've saved your images. And so here, since I've clicked add folder, I will just select this folder and then press select folder, and then all of the images will be uploaded. And I get this window here, and it asks, are all these images taken by a single camera or by different cameras? And so here, they were all taken approximately the same time with the same drone. I will click single camera and say, okay. Then you can take a browse at all the images. So here you can see this is the outcrop. We're going to be imaging this. We're going to be building an SfM model of this outcrop. So we can just look at some of the different pictures, and looks like, I hypothesize that the drone was flying around this rock outcrop and was taking images from several different perspectives. So the first thing that we want to do today, now that we've loaded the images is to align the photos. And so that's going to be to create this sparse cloud and do the bundle adjustment, which will give us, that sparse cloud as well as camera locations. So we're going to go back to workflow, and then Agisoft makes this fairly easy. So the first processing step that you want to do is the first thing here, align photos. So we're going to select that. And then you have several options here. So the first is the accuracy, which is essentially the resolution of the point cloud that you're going to make. And so for today, we're going to set that to medium, because we want this to finish in a fairly timely manner. If your computer is slow, then I would suggest for today's demo that you use low or lowest. And of course, you can always come back and process again at a higher resolution. And incidentally, when doing research scale SfM processing with larger data sets, I do like to process actually on low or medium at first to just understand the data that I've collected and what some of the future errors could be. So we're going to say medium, and then I typically leave as generic pre-selection and then reference pre-selection checked. Although if you don't have georeferencing, then the default probably is not for the reference pre-selection to be selected. Press medium and say OK. And so when data sets are processing, Agisoft has this window open, which tells you approximately what it's doing and then how much time is left. Yes, as Carissa says, this is a key part of the SIFT, which is the scale invariant feature transform, as we heard Ramon talk about earlier today.
Yeah, and so this is why a lot of software packages have now implemented this process, because it's essentially these open, well-known algorithms, the SIFT algorithm and the MVS, the multi-view stereo, are the two core components of this workflow. So different software packages call this process different things, but fundamentally it's SIFT plus MVS are the two steps in the core SfM workflow.
The expectations for what we generate from this step are both the sparse cloud as well as camera positions. And as default, Agisoft shows the sparse cloud. And so you can start to get a sense of the 3D structure of it that we are able to see in the images, where we have this outcrop here, which is green and brown, surrounded by lower elevation area. And then you can also put on this, press this camera button here. So at this first step, Agisoft has used the SIFT algorithm, and it gives us this point cloud as well as the camera positions. And so we see that we have this 3D object here, and then the blues are the camera positions. And so we see at all times they were looking at the outcrop, and they were flown at these two different circular paths. And there's different drone software that will actually let you program in to automatically fly in this circular path. So the next step is to build this dense cloud. So it's going to take the sparse cloud as well as the camera positions, and then build this much denser cloud using the SfM techniques we talked about earlier. And for speed today, we want to set it on medium, although you prefer first to speed it up, you can use low or lowest. Okay, so this is now finished processing, and to see the results, you then want to come down here to Workspace and click Dense Cloud. And then when you've done that, you can now see the image or the dense cloud that you've made. And so First, you'll notice it's a lot more data, 3D data that's here than was in the sparse cloud. And it has color. You can see good detail of the rocks, the trees, and then the surrounding town. And so this dense cloud is one product that you may be quite interested in exporting for use in Cloud Compare. I'll show you how to use Cloud Compare for a different data set in the afternoon. But to export the dense cloud, you go up here to File, you say Export, Export Points. And then the default is to export the dense cloud. And it gives you first an option to give it a name. And then this later step here is that you can choose the coordinate system that you want to export your data set to. So the default is WGS 84, which is latitude and longitude. But then you can also select many other data sets or other coordinate systems to export your data set into. The option of processing is their way to speed up. So one thing I like to do is just let SfM process overnight or over a weekend and don't think about it. And so one way to set it up to do that is to go to Workflow, Batch Process. And then here you can lay out your whole processing workflow for SfM. And I think something that's very important to do is to have it save the project after each step. So you'll find that it often has issues and either quits or stops, but it's very useful to have everything earlier well saved. And this is really the way to speed up the processing and take the time or decrease the amount of time that you have to spend in the processing steps. I'd like to process lower resolution first, make sure it works, try to anticipate some future issues before processing at high. And I typically don't process at highest. So at that point, it tries to take all of the image or all the image information in the images. And at that point, it'll actually add in some noise. So the best resolution that I process is typically highest.
And then other factors that drive processing time are the resolution of the images. So if you're shooting with a super high megapixel camera, you're going to have more pixels. That means it's going to take longer to process. And also just the sheer number of images that get dropped in. So there is this is definitely a case where you can produce really nice models with, but being modest about your image inputs. You can kind of you can throw a ton of imagery at the processing workflow that may not necessarily improve things once you get to a sufficient amount of overlap, but will dramatically increase processing time. And this is, I'm not sure there's a great, I don't know, Chelsea, if you've got suggestions on that, but there's not necessarily a great exact science to that. But probably comes from experience a little bit about programming your drone flights and how much overlap you have and how many photos you collect.
It does. I would suggest not putting your overlap at less than 33%. I typically put it at 40% just to have a little extra, because if you're back in the lab and you didn't take enough images, you can't really go back.
And this is also a place where people oftentimes will bring a computer out in the field with them that has has Agisoft on it and do that initial processing at, say, low, just to make sure that your model converges and that you do have enough overlap in your images. So when after you've been out flying your drone or taking pictures all day, you don't get back to back to your office the next day and realize that you screwed something up in your data collection and you missed it. So doing an initial process in the field is usually a good way to wrap up your collection. Just make sure things are working.
All right, let's go do the next step, and then we can come back to some of these questions. The next step is to build a mesh. We go build a mesh here. It will build it from the dense cloud. The other common option is a sparse cloud, but it'd be, I think, very rare that you would pick that as your option. And then we will also work with medium. I found, incidentally, that particularly Metashape has issue doing a high resolution mesh. So often actually just use a medium mesh, even if I processed other parts of the project at higher resolution. It's probably actually the longest step that we will process. So this is now done. So this is still the dense cloud, but then to see the 3D model, which is generated as a mesh, come down here and click 3D model. And here it is with color. You can also see it as a solid wireframe model. So these types of outputs are typically used, for example, for 3D printing. I think scientifically, otherwise, at least I have not used them.
The meshes are also, if you're somebody, I can't remember who in the introduction was talking about kind of like virtual reality outcrop models and sort of virtual field trips and those kinds of things. The meshes become useful in those kinds of environments. Like you want to go into like Unity or one of those software packages, the mesh would be probably the best way to do that.
But the mesh will then let you build in a texture model, which is, I think, actually a very good way to visualize the data set from inside, to essentially paint it in and see it as a high resolution. We'll just let this texturing step run. So here is the textured map, which is 3D mesh, but then now with the colored filled in. So it's a very high resolution way to image the processing. Zoom in, look at the outcrop, more detail, as well as any of the infrastructure. So I believe this is the last step that you can do without licensing the software, or perhaps without a trial version. So I'll just show quickly a couple extra steps that you can do with the licensed version. So we've now done through the texture. I rarely do the tiled model, but then what else is very, very useful is to build a digital elevation model and then the Ortho Mosaic. You can first do the DEM, digital elevation model. And so it has several questions or options. First is this coordinate system, and the default option is WGS 84. And then you can have the option to build it from the dense cloud, which is what I typically select. And come down here and look at resolution. So it will build an 11 centimeter digital elevation model. It builds it as a raster data set. So in this case, just under 3000 by 3000 pixels. And say, okay. And then, yes, it tells you, it prompts you to save it before it will process the digital elevation model. So then you have to go back and generate the saving. And then it saves the project. So then we can go back to building that digital elevation model step. This one is quite fast. So then we can come back down to this handy dandy workspace, and then find our 11 centimeter digital elevation model. So as we expected, we do see this high elevation of the outcrop surrounded by lower elevation. Then final processing step is to build an Ortho Mosaic. So again, you have similar options, and it offers the default to build the pixel size in latitude and longitude. To get a reference of what that is, it's about 0.03 meters to 3 centimeters. And so the Ortho Mosaic is always going to be higher resolution than the digital elevation model, because you can have one pixel of your Ortho Mosaic representing one area of the ground. But then to build the DEM, then you need one area on the ground, or 4 areas, 4 pixels on the ground to build 1 elevation pixel. And so the digital elevation is always going to be lower resolution than your Ortho Mosaic. The Ortho Mosaic does also take longer to run. Just going to stop this. I wanted to show just a couple other things first. So one very useful thing to do is to export a report. So you go to File, Export, and then go down to Generate Report. And so we'll call this Italy. So it lets you select a name and then select where you want to save it. So right now it's writing the report that describes the processing that we've just done. And then here's the report. So here's the ortho image, or no, just a downward facing image of the data set. Survey data. So this here, each color represents the number of times that part of the ground was imaged by a camera. And so we see that every area was imaged more than 9 times. So we expect to have a fairly high resolution or high quality data set here based on the good design of the flight geometry. Gives you information about the camera locations, digital elevation model. And if you did add georeferencing, it will give you some statistics on your georeferencing steps and the accuracy there. And so remember, when you've done all of the processing, you want to export the data, you can come down to export points, which will export the dense cloud. The mosaic, we haven't built it yet, so it's all gray, but you have the option to export the mosaic as a JPEG, GeoTIFF, PNG, as well as a Google Earth product. And then very similar options for the digital elevation model.
Chelsea, Jill is it easy to filter sparse vegetation and DM creation? So can you go to your tools and click on that dense cloud filter option? So dense cloud,
yes.
classify ground points. So this is a tool that is inside of Metashape that will attempt to run a LiDAR-like classification on the point cloud to differentiate ground points from everything else. And this is a relatively new addition to Metashape. And I don't know the exact algorithm that's running underneath of it. Like, it's a little black boxy, but there are definitely lots of different tools out there for running ground classifications on point cloud data. And this is one, and it's certainly, if you're in Agisoft and you have access to it, it's certainly worth exploring. There are some parameters that essentially define how you're going to do this. A lot of these algorithms are sort of de-spike oriented. So they're basically looking for large curvatures in a surface that's constructed from the point cloud. So any point that causes a massive deviation from a surface would be considered to be vegetation, right? Because standard ground models, when you're out walking around on the ground, normally you don't step meters and change in elevation over short distances, unless you've got like a cliff in front of you or something. And so this is a tool that will do this. There's lots of other tools that come from the LiDAR world that are meant for classifying point clouds. And so I've not played with the Agisoft version very much, but I've used tools like Last Tools and some of the other open source software packages to do this on LiDAR data. And so your miles may vary as a function of how much ground is visible in your model versus how much is just pure vegetation. Because again, since this is an optical camera-based technique, if the picture doesn't have a ground in it, it's going to be pretty hard to differentiate, to create ground from something that doesn't exist.
Running their ground classification in Arizona in a place with fairly sparse vegetation, I found that at least with the default parameters, the ground classification did not work all that well. And so I would approach this with a little skepticism unless you work hard to calibrate these to your local area. Otherwise, I might look for last tools, which even with working with drone data in a medium vegetation area, I found actually did work quite well. So you might look here and notice many of these points are realistic, but then the points over here basically look like it's the ocean, but at high elevation. So it's not really realistic. So you can come in and essentially put a circle around points and then delete them. And so I prefer to use this freeform selection tool to let you then circle the points that you want to delete. Then it highlights them and you can just press delete. And so this would take a little bit of care to fully remove all of this apparently floating ocean, but you can do it. You also can get this example with sky that is just in the wrong place.